Hey everyone, welcome back. Today we are discussing the last principle, dependency inversion principle. This topic is also very simple and dead easy, guys. Easily you can understand about this principle. So very important. Solid principles are very important as part of interview questions. Pressure level, no one will ask you, but once you are experienced person, definitely they will ask you these type of questions. So please go. If you are the first time you are watching this video, please go ahead and watch about remaining principles as well. Okay, link will be available in the description, guys. Okay, now let me start about what is dependency inversion principle here, guys. Okay, now basically what this principle says that high level modules should not depend on low level modules here. Both should depend on the abstraction. Already we are following this concept, guys, but you should be aware in Spring framework mostly we are using dependency injection, right? Auto wiring, that is the where it is comes to the picture. High level module, what is low level module? Why? Both should depend on the abstraction. That is the one we are going to discuss now here. Now come to this point. Now without dependency inversion principle, okay, what is the problem statement we'll discuss, and how you can refactor this principle in this problem statement here. If you see here, we have a class called email service. What this service will do, we have one non-static method is available here. I written one method called send email. Whoever using this service, they can use send email method. Okay, till here we are good. Okay, sorry. Okay, let me take a pen. Now till here we are good. Email service here. Now we have called notification service. If you see in notification service, I created one email service object. If you see here, notifying the user, I am using send email method. Now it's good. But if you see, I am hard coding tightly coupled email service with notification here. This is called high level class here. Notification service tightly coupled with low level class. Future, you have a requirement, you want to support SMS and WhatsApp also. Then what we need to do, we need to change. We need to change this notification service logic. Now, changing this piece of code is one principle. Open closed principle also it is affecting here. OSP, right? Open for extension, closed for modification. That also this principle is violating here, and testing becomes harder. This is a problem statement if you don't implement the dependency inversion principle here. How you can refactor this piece of code means, see here, after applying dependency inversion principle, see here, here we have a message service. I want to send a message. Now I taken as a interface. You taken as a interface. You have a email service. You have a SMS service. You can take a WhatsApp service. No, you can add new functionality also. Adding a new principle called OCP, already open closed principle. Now, if you see, message service is a loosely coupled now. Whoever they want, they can pass the subclass object. Liskov substitution principle. Who are required subclass, they can make it as an email service, SMS service, WhatsApp service. No need to change any code here, here. No, everything as it is keep. Just create another class by creating WhatsApp service. So now it leads to loosely coupled here. Now here if you see, high level is notification service depends on abstraction, not concrete classes. That is the meaning. High level classes should not depend on low level. Instead of, we should be depend on the abstraction. Here abstraction means message service is the abstraction for us. This is the real concrete classes implementations. So easily I can swap email with SMS or WhatsApp without changing the logic. So by doing this activity, it is supporting both open closed principle and inversion of control. Both it is supporting here. This is about dependency inversion principle. The real world analogy, like you have a socket, right? You have a phone charger. Okay, old phones require a specific charger is required. Now, by following dependency inversion principle, your phone is depending on standard USB port. It's a USB port. Just you need to depend on the abstraction. That's it. This USB port can provide by like a OnePlus, Macromax, and Blueberry, or whatever mark, a EMI. All these chargers will support that USB port. So we should be depend on the abstraction. We should not tightly coupled with our classes here. iPhone, that is completely a different abstraction. All iPhone related things, Android related things, standard USB will be support as well. So your mobile phone depends on abstraction, not specific implementation. If they implement that approach, suppose if you are using OnePlus charger, you are using, if you don't follow USB, only it support OnePlus, means it's a difficult, complicated here. So that's why flexibility, reusability, and you can decouple application as well. This is about dependency inversion principle. Overall, let me recap about the solid principles. S represents single responsibility, one class, one reason to change. Okay, open closed principle, open for extension, closed for modification. Liskov substitution principle, subtypes must be replaceable with the base types. Interface segregation principle, don't force classes to implement unused methods. Dependency inversion, it depend on the abstraction, not concrete classes. By today's session, successfully we completed the solid principles. Be prepared interview questions. Whenever I have a time, I will prepare different types of interview questions on solid principles in interview room, how they will ask scenario based also. I will come up with the future sessions as well. Okay, so I'm expecting your feedback on these videos so that I can do different kind of topics interview perspective as well, guys. Okay, thank you very much, thank you for watching, guys.